This is going to be my intro to cellular energy video. And of course, all cells need energy. Things that we've talked about in class so far, or that we will talk about in the course, that cells need energy to do. Obviously, active transport, you need energy to move things against their concentration gradient. To move around, it takes energy for us to move places. To grow, for our cells to divide so that we can get larger over time, and protein synthesis, which is basically going to be carrying out our genetic code. So that takes a lot of energy. Our cellular energy currency in our cells is going to be ATP, which stands for adenosine triphosphate. This is like energy money. If you want to get something done and it requires energy, you use some ATP. ATP, you can sort of see here, this section of ATP that I've drawn in black is the adenosine section. Note the A over here. We're going to talk more about molecules like this when we get to DNA, but you should know that ATP is a nucleic acid. So one of our major macromolecules, okay? And then let's think about triphosphate. What do we hear there? We hear tri for 3 and phosphate for phosphate groups. So here in adenosine, we have adenosine and then 3 phosphate groups, okay? Now, phosphate groups, you should know, are negatively charged. And negatively charged things do not want to be very close to each other. Think about what you know about charged items. Opposites attract and like charges repel. And so, of course, having 3 very negative molecules next to each other, they don't want to be there. So it takes a lot of energy to put these molecules together and attach them to each other. And so there's lots of energy stored in the bonds. So the energy of ATP is stored in the bonds that connect the phosphate groups, because it takes a lot of energy to hold those together. So that bond is very strong and it is storing energy. So to use ATP, you will actually end up breaking off the third phosphate group. So you break the bond between the second and third phosphate, and then you get a molecule with 2 phosphates, energy, and a separated inorganic phosphate, and you typically see this with a lowercase I next to it to represent the fact that it is inorganic. Let me write that in. Inorganic. Okay, we get energy, and then let's just think, if a molecule with 3 phosphates was adenosine triphosphate, our molecule with 2 phosphates is actually going to be ADP, which stands for adenosine diphosphate. Di here meaning 2, similar to our vocab word from biochemistry, dimer. And so we can have this cycle where this ATP is sort of the only 100% renewable energy. That you might see, okay? So we start with ATP, and on the right here we end up using energy, right? So you can use the energy. Energy goes off, okay? And you lose your phosphate, so you're breaking that bond, and then you end up with ADP at the bottom. And ADP can become ATP again if you give it energy and add a phosphate group back onto the end. You can think of this like a rechargeable battery, okay? Like you might see on your phone. If I draw batteries here, okay? ATP is like a fully charged battery. Okay? ADP, on the other hand, is only partially charged. And so by adding energy, I can fully charge my battery and turn it into ATP. If I want to use energy, like using my cell phone, I use energy and my battery decreases.